Thomas Kolb. How do you know where a black hole is supposed to take you? I would like to get one incorrect, an apparently common idea dismissed as soon as possible. A black hole is not a portal. It is not a door into another universe or to another place in our own world. It is not a bus station or an elevator or a secret passage to your daughter's bookshelf in the past. A black hole is in fact nothing magical, just a very, very, very heavy lump of matter that is so massive that it will create a gigantic gravitational pull on anything around it. Close enough to it, all trajectories lead to its very core, to the so-called singularity. Matter drawn into the black hole will smash into the core and become a permanent part of the black hole until the end of times, or until the black hole evaporates through its excruciatingly slowly draining Hawking radiation. The only peculiar thing about black holes is that they warp spacetime to such extremes that it actually creates a halo of absolute secrecy around it. It does not just swallow matter and radiation, but also information. It is the ultimate paper shredder, so to speak. All information is perfectly concealed inside its event horizon, never to be revealed again for as long as the black hole lasts. Whatever happens inside the event horizon, stays inside the event horizon. This may not seem particularly strange first, but the weird thing with information is that by very definition, it can never be destroyed. A paper shredder may make a letter more hard to read, but given enough time, you will be able to puzzle together the pieces and decipher the content. Even if you burn the letter, it is possible to reconstruct the text by analyzing the motion of the smoke particles and the pattern of the heat dissipation in the room. You and me may not be able to do that, but in theory it can be done. But a black hole, really, and inevitably destroys information, which seems to violate the foundation of physics as we know it. Anything falling into a black hole will end up exactly the same, regardless of its initial state. The only thing that alters the state of the black hole is the swallowed stuff's mass, electric charge, and angular momentum. Everything else becomes equal. Even if the stuff was ordinary matter or antimatter, does not make a scrap of difference after that the black hole has swallowed it. There is no way to ever find out which one it was. It is like if the black hole removes those thousands of intrinsic properties of the matter falling into it, and simplifies them just into these three fundamental ones. This is still one of the remaining great mysteries of the world that brilliant minds like Stephen Hawking tried to solve. Why can't we see what happens inside a black hole? Could we not just send a spaceship with a camera into a black hole and have it transmit a film sequence as it falls in? Well, if you would be looking at the transmission from the spaceship falling into a black hole, you would see the movie slow down as the spaceship gets closer and closer to the event horizon. The individual frames that make up the movie would start to come more and more seldom, until each pixel would take days, weeks, months, and then years to arrive, and then finally no more transmission is received ever. The image of the spaceship as you look at it through a telescope will turn first red, then become infrared, shift into microwave and radio, and finally fade out of existence. You would never actually see it go beyond the event horizon. You would never know for sure what happened to it. Interestingly enough, if there was an astronaut on board the spaceship who would be watching the world receding in his rearview mirror, he would see the same thing happen to it, just the very opposite. The world would appear to speed up tremendously, but the light from it would quickly turn blue and ultraviolet, get dimmer and dimmer as it is shifted towards the X-ray and gamma-ray range, and finally all light from the outside would fade away into darkness. If it is a supermassive black hole, like the one inside the center of our galaxy, nothing particular would happen on board to start with after that the spaceship has passed through the event horizon. Things would appear quite normal on board. You would not even feel anything until the very last seconds, when everything suddenly becomes unfathomably violent. The spaceship would suddenly be ripped apart, not just to pieces, but into individual atoms that would then fall down onto the surface of the black hole with a big splat. And that would be it. But hey, you may say, I have seen photos of a black hole. Here it is. So you can actually see what happens there, no? Yes, it is a picture of a black hole in the center of another galaxy, called M87. But it is not the black hole you see. The orange glowing stuff is the stuff that escaped being eaten by the black hole and is now rushing outward. It is the dinner of the black hole that was too much to swallow. The actual black hole would be a tiny, tiny black dot in the center of the image. You cannot see it, because it would be far smaller than a pixel on your screen, but it is there, rest assured. Going back to the question of flying a spaceship into a black hole. Well, there are some problems with that. The first one, obviously, is that even the nearest black holes are incredibly far away. The closest one that we know of today is called HR 6819, and even that is 1,000 light-years away from us. The fastest spaceship that we have ever launched, the Parker Solar Probe, would take about 20 million years to get there. The second reason is that a black hole is not left unguarded. It is in fact surrounded by a moat of gas and dust, rotating and swirling around it at relativistic speeds. The orange glow in the image of the black hole above, remember? It would work as an absolute meat grinder, slicing and ripping everything to shreds. Also, the swirling gas emits gigantic amounts of synchrotron radiation that would fry every kind of electronics or human tissue in a heartbeat. It would be like basking in the very glow of the exposed core of Chernobyl. And finally, a black hole's gravitational pull is highly uneven, which means that towards the black hole, the gravity is several times greater than just a few centimeters further out. Basically, if a spaceship would be falling with its landing gears first into the black hole, the landing gears would accelerate much faster than the top of the spaceship. The gears would thus be ripped away from the fuselage, and then each consecutive part, inch by inch, ripped off until the entire spaceship is just a thin thread of sparkling atoms, smashing into the surface of the black hole. And that would be it. 105.4K views. View 4,667 upvotes.